Hey, this is Shri.
And as well.
Welcome to the Technium, where we talk about the edge of technology and what we can build with it. An optimistic look at the road ahead. How's it going, Will?
Yeah, it's going all right. I guess that was a little bit extra, but I guess we'll just live with it. What are you drinking today?
I am drinking Voodoo Ranger Juicy Haze IPA. So it's a kind of sour IPA, one of my favorites.
I see. I am drinking some leftover espresso that at the end of the day, it's cold coffee. It's good, I promise. But we have an espresso machine here because my partner has been working on getting much better at espresso. So that's what I got this time. So sorry, no brand, but it's what I need to stay awake today.
Very nice, cool. All right, so I'm pretty excited for this topic. Have you heard of Webassembly before?
Yeah, I have. It's made its rounds on Hacker News and whatnot for the last couple of years, and I think people have been excited about it for a while, but it's taken some time to ramp up and for the ecosystem to round itself out. And I think we're only beginning to see some more people paying attention to it, because I think it's at a point where you can actually leverage it for gain and benefit when you're building apps.
Yeah, so WebAssembly as a technology is sort of hitting its moment right now. So it's a binary instruction format for a virtual machine, initially targeting the browser, but there are a lot of projects that are trying to bring this virtual machine to run on all kinds of platforms. And the idea of it is that it's sort of a portable format which can be compiled to from a variety of programming languages. And like I mentioned, it allows you to target both browser-based client-side applications as well as server-side workloads. And so it's this kind of holy grail, right? So we've seen virtual machines before that are trying to be this like write once, run anywhere type of language. And
AKA
it's possible.
Java in the 90s or so. So yeah.
Yeah, exactly. So this is a familiar story, but I think people are now feeling like it could actually happen with WebAssembly, which, by the way, goes by the abbreviation WASM, which we're just going to go with WASM.
Yeah, how else would you pronounce it?
WASM.
WASM. No, let's go with WASM. Anyways, let's go forward. So yeah. I think it's pretty interesting on multiple fronts. And one of the questions I have is like, what's different this time around? Because we've, like you said, we've heard this story before. But that said, a lot of people are excited about it because it has a couple different properties that makes it suitable for building certain kind of applications that you typically wouldn't do with JavaScript, or you wouldn't think about doing. One of the main core things that WebAssembly gives you is speed, because you have any type of language that you compile to WebAssembly, and then the browser can run it. And usually when a runtime doesn't have to interpret a programming language to run it, like, you get a lot of speed as a result. It's secure. That's kind of the second thing that people are really excited about it. Like, the code that's running in WebAssembly is sandboxed because they're thinking about security from the beginning, because this was meant to be executed inside a browser. And, like, browser people are very much, and rightfully so, pay attention to security. And then the third thing is where it's kind of like the WebAssembly format is open, readable, and the idea is that it's a lot easier to debug, right? And then lastly, like, the idea is that it's portable so that you can not only compile various different languages to WebAssembly to target the browser, but also you can target multiple other compile targets, from backend servers to serverless, our favorite technology server, serverless, as well as I think embedded systems as well. So yeah, I mean, I think that's kind of like a general overview for like what WebAssembly buys us.
Yeah, I think WebAssembly is a weird name in that it's not really much to do with the web at all. I think initially it came out of this project called ASM.js,
Mm-hmm.
which was a kind of subset of JavaScript, which was supposed to be very easy for the JIT compiler to optimize. And then it sort of grew from there. And now at this point, people are talking about running, WASM in, like you mentioned, maybe embedded systems, but definitely a lot in terms of server-side, web servers and things like that. And so, yeah, it's sort of ballooned into this vision, which is that you can write in a variety of languages and run it in all these different contexts. And the amazing thing is that they've actually gotten a lot of adoption in terms of the open source community targeting WASM for a variety of languages. So I think almost every major language that you can think of has some level of WASM support. If you go on GitHub, you'll be able to find some way to compile most major languages down to WASM.
Yeah, there's an awesome list of languages that compile to WASM, and I mean, Brainfuck's on the list. And so if Brainfuck's on board, then it's got like widespread appeal among various different programming languages. Yeah, and I think one of the holy grails of any computer ecosystem is when you have end consumers and end producers. Like in this instance, it's the programming languages with all the different compile targets, whether they're browsers or backends. You get a matrix problem of n by m connectors that need to be written. But if everybody could only just agree on a single format as an intermediary, then you would only need to write n plus m different converters. And that's effectively what WebAssembly gives you. And the analogy is like what the Internet Protocol IP did for networking. The term is narrow waist. And because there's a lot of programming languages down to WebAssembly, and then it comes out again to various compile targets. So IP did that for networking, and Docker containers did that for deployment.
Yeah, it's a good point. A couple of years ago, 5 or 10 years ago, where people started talking a lot about sort of polyglot development, where in a given company, you sort of use the best language for the job. And so you might have workloads that are, Node.js, you might have workloads that are Ruby, or depending on whatever the context is, within one company, you might have multiple languages being used. And so maybe the dream with WASM is that you'll actually be able to compile these down to a single representation and then run them kind of homogeneously.
Is that prevalent in the companies that you know of? Because for me, I switch between a lot of languages. I can never remember the syntax for the switch statement. Anyways, like I just never remember. Yeah. Like, so is this the case in a lot of different companies that they would need to have multiple languages compiled to the same intermediate representation, like WebAssembly?
I think it inevitably happens whether you want it or not. So, I mean, the company that I work for, we have C++, Go, and Java. I've worked at companies where it was Python and Java and Go.
Oh, I thought it was dictated, like you're not going to be like running Elixir or like Haskell, God forbid.
Yeah. So I mean, I don't think you're going to work around those organizational issues. But actually, one of the reasons why a lot of companies are prescriptive about the languages that can be used is because of the operational cost overhead of maintaining the variety of different languages, and then they each have their own bespoke way of monitoring them, their own type of package managers, et cetera. And so, at least operationally, it things might be simplified if you do have a single compile target in Wasm. Although, there are, of course, going to be other tooling issues with supporting multiple languages anyway.
I see. I can see that. So I think the Wasm is also interesting in the sense that Solomon Hykes, the founder of Docker, quipped on Twitter before that if Wasm and its standard WASI, which we'll get into later, had been available back when he was inventing Docker, he probably wouldn't have done it because it would have served nearly the same purpose that Docker containers do today.
I saw that tweet back when it came out. It was very, very thought-provoking. And I think it does relate back to what we're talking about with the operational overhead. So Docker was the first mainstream use of containers to package up a program and all of the resources that it needs to run and make it so that it's a kind of homogeneous workload that you can ship off to is any kind of a server environment. And you don't need to worry about the specific workload and tailoring the server to that specific workload. And now Docker has sort of faded away and there's a whole ecosystem being built around Kubernetes, which is again solving the same issue, which is how do you have these workloads, how do you package up your compute requirements into these nice little containers and then ship them off to these Kubernetes runtimes that just take these and run them regardless of what's in them. And so it's definitely possible that you could do the same with Wasm. I think there are projects that are in progress to build basically a Kubernetes of Wasm programs. And there's also an interesting change now because there are a lot more companies these days that are interested in pushing compute to the edge. So you have things like Cloudflare and Fly.io, which are these platforms that take containers or a variety of workloads and run them basically on CDN infrastructure. And so I could definitely see a opportunity for those kinds of platforms to accept Wasm programs and run them close to the users and be able to have responsiveness and speed and things like that.
Yeah, so I guess that's a good segue into the next segment that we usually talk about, which is what does this let us do that's new? And maybe in some sense, we had this broad overview where we're kind of getting ahead of ourselves. But what does it let us do that's new? And one of the things that you talked about earlier was edge compute. But for those of us that don't know what edge compute is, glossed over it for a bit, but do you want to kind of tell our listeners what edge compute is?
Yeah, so it's kind of a new emerging paradigm, at least in terms of actual usage. But the idea is that you run your program close to the users that are actually going to make the requests. So rather than having big central servers running in a few core data centers, like you would if you had AWS EC2 instances or things like that, edge compute is this idea that you can use basically a distributed infrastructure provider like, let's say, Cloudflare, that has presence all throughout the world, and be able to push your servers kind of throughout their distributed network so that when a user in a particular location makes a request to your service, it's being serviced by a server that is close by them. And so you kind of fan out your computation throughout the globe, and you basically treat this CDN network as a global computer.
Right, because before this sort of thing was available, typically how the back-end web architecture is that back in the old days, they had computers that had backup generators, but the short of it is you would have your application servers next to a database somewhere in the cloud, but usually it's co-located in one geographic location in the world. And so that's all fine and well when your users are somewhat within that geographic area, but if they're on the other side of the globe, you can see really large latency as it's hard to beat the speed of light. And so what then people have done is they've leveraged CDNs to serve up static information or cached information in the CDNs, the content delivery networks that are close to the user that's requesting it. So they see that information very quickly, and then any sort of dynamic information would go through the CDNs back to the centralized servers in the geographic area before kind of coming out again. And so what edge computing does is it doesn't get rid of that central server entirely. I think in some cases it does, right? Because if you can deploy your backend programs on the CDN itself, then it never needs to make that round trip, right?
Yeah. And I think actually there are a bunch of interesting projects now that are trying to push things like data out into the edge. So there are distributed databases as well. So I think there's still some need in the current state of things where you need to ping a central database or that's running in some data center. But I think that might actually be smoothed over as well.
Yeah, well, that's a different topic for another day, because distributed databases sound like a nightmare to me operationally. And so going back to kind of WASM, like what's different about WASM spitballing itself into this particular application for edge computing? Like, could you do this before WASM, or does WASM enable this to happen?
I think that WASM has a huge advantage in terms of its speed. So I was looking a lot into what's the difference between WASM and the JVM, because it's an obvious comparison. We made it ourselves.
Yeah.
The biggest thing that I could find is the speed and responsiveness. So if you have ever used a Java program, it takes forever to start up.
There's a cold start problem with the JVM programs. I thought they did a lot of bug fixing and features to mitigate that problem, but I guess it's not something that they can completely get rid of. Do you have a lot of experience with that?
Yeah, and I don't know too much about it. And I know there are some interesting projects like Graal VM, which is sort of related to this JVM ecosystem, which are trying to solve this.
Yeah.
But if you think about WebAssembly specifically, it is meant for the use case that you hit a URL and you download a WASM program and it runs. And the expectation with the web is that it should run pretty fast. And so they've done a lot of optimizations, like doing streaming, compilation, and a bunch of other compiler-y things, which I don't really know too much about. But the sort of upshot of it is that you can basically take a WASM program and have it running, within milliseconds, versus having this cold start problem that you do with a lot of other virtual machines. So Java is the one that comes to mind, but even things like .NET and people were even saying Flash, if you remember, was a kind of virtual machine.
Yeah.
And it also took it a long time to load. And so speed is a huge advantage. And this is really important for these type of serverless edge compute use cases, because the idea is that your edge compute provider has a repository of a ton of WASM programs it could run, and it has them sort of saved and cached somewhere in all of its data centers throughout the world. And it doesn't know when somebody's going to request that your WASM program is going to run. So it's very important that when somebody does request that your WASM program or function or whatever runs, that it's able to spin it up very quickly and service the request and potentially spin it down very quickly as well. And I think that's something that WASM gets you that you wouldn't be able to do with a JVM program.
Yeah, that seems to be in line with the sentiment I got from reading about people using serverless in their stack. Like, they lament the fact that the cold start times are so long, because a lot of times the serverless service might just kill their thing or spin it down for whatever reason, because you're not in control of that. And then if it comes up again, and it takes, I guess, on the order of seconds to service a request like that, that can easily back things up for you. So depending on your application, obviously. So that seems like it's a win for serverless with WASM. Do you happen to know why Wasm doesn't have this cold start problem?
Yeah, I think I don't know too much about the specific optimizations they've done. I think a big one is the streaming compilation, so that when you're reading the program from the network or the disk, the basically the virtual machine or the interpreter doesn't need to have the entirety of the program before it can parse it and start executing. So it's able to basically, as it reads off of disk, it's able to start doing the hard work of spinning up the whatever context it needs in order to run it.
Wow, they thought of everything. That's pretty impressive, actually, because I guess as an aside to IDE tools, a lot of times there's this latency when you're updating stuff because the underlying compilation tools themselves requires like an entire pass or something before. And so if it's streaming, yeah, well, I wonder if it would be a boon for like WASM tools and whatnot. But this is just me waxing because I don't know for sure either.
Yeah.
But anyways, back to kind of applications of WASM. Like what does it let us do that's new? So we heard about edge computing, and that makes sense that it can help alleviate that cold start problem. Like, do you know of like other things that people are using WASM for today?
Well, I think we've gone deep into this edge computing, which I think is super cool. But the original promise of WASM was that you can run a bunch of stuff in the browser. Like this was the original premise, and then it sort of exploded from there. Yeah. And so I'm actually really excited about some of the things that you're able to do using the browser as a compile target / runtime. A project that I've seen is one called Pyodide. It's trying to bring the entire Python data science ecosystem into the browser. So things like NumPy and Pandas, as well as all the plotting tools and things like that. And so I've seen some very cool demos where they're able to take things that you see and typically associate with Jupyter notebooks and actually have them running entirely in the browser without having a Jupyter runtime that you're issuing commands to.
Yeah, I think that may be able to help with building kind of collaboration tools around it, because I know when I was looking in the space, a lot of data scientist teams were lamenting about how it's hard to share notebooks between them because Git is not very good at having differences. It's hard to collaborate over it. And so a number of companies sprung up to kind of help with this deficiency. So I can see how having Pyodide would help with that. The other type of things that I've seen in the browser are things that you typically associate with desktop apps. And so the two I was going to mention was FFmpeg, which typically is a library where you can process video in a myriad of ways, from converting them to scaling them up, scaling down, and filters, so on and so forth. And so somebody decided to use the source for FFmpeg and compile it to WebAssembly and then deploy it on the browser so that you can build video editing apps in the browser. So before, you wouldn't think about building a video editing app in the browser just because JavaScript is just too slow for something like that, right? But when you have this now, then it's something that is now available because you don't need to send the video, even streaming wise, to a backend server to wait for it to process it and for it to come back. So that is something that is pretty exciting. Another one that I've seen is SQL.js, in which somebody took SQLite source code, compiled to WebAssembly, and then deployed it in the browser. But basically, like the idea is that you're able to bring these sort of things into the browser where you couldn't do before.
Interesting. Yeah. So FFmpeg and SQLite are typically things that you link in to programs that run on the desktop. And yeah, so if you have these running as WASM modules or libraries, then you can basically build desktop quality programs entirely running in the browser, or maybe running in a Electron shell or Electron wrapper or something like that. But you'd be able to basically access these from JavaScript and pretend like you're a proper desktop programmer.
Yeah. Yeah. As an aside, one might wonder why you would take a desktop app compiled to WebAssembly and run it inside of an Electron app. But I think the point is just that there's, I guess in this case, you would just kind of compile directly to that compile target if your toolchain allows for it, I guess.
Well, so actually, I will interject and say that in the editing of this podcast, we use a tool called Descriptor. We've mentioned this before in the Local for Software episode.
Yeah.
It's basically, I don't know its specific tech stack. It seems kind of like an Electron app.
Yeah, it feels like one, right?
Yeah, and so it has a bunch of things that are very, feel like a web-based tools for good reason. Like it has a text editor, which you can, modify the text and things like that. But it also does a lot of work that you would typically associate with a desktop app. So it edits video. You can do some type of sound processing with it. And I don't know where it does all this work. I imagine it's actually doing a lot of this work in the cloud, I guess. I'm not sure. But yeah, there is definitely a use case for having this like mix of, using web-based UI components where it's appropriate, because actually for rich text editing, the web has some of the best tooling available. And then using things like FFmpeg when you need to for kind of heavy-duty processing.
That would be an interesting future episode about like what are replacements for Electron. But anyways, that said, I definitely see the application in Descript because like it's pretty process heavy, and like for you have to wait for the video to download entirely to your computer before you can do any editing, right? And so like distribution aside, then that might be useful if you can operate on things without having to wait. So then the I'll mention like two other areas. One is the original demo for the precursors to WebAssembly, which is games, because I remember there was a demo of some sort of Unreal Engine C++ demo that they compiled to asm.js and then ran it in the browser, and everybody was like,
it was actually really good. It was like hitting like 60 FPS or whatever.
Right.
Like crazy. Yeah.
And everybody is like, whoa. And so I can see games deploying on the web, although I'm not sure exactly why they don't. Maybe it's a distribution issue, because like right now the game ecosystem, as far as I can tell, like if it's on mobile, it's usually in the Google Play and like Apple Store for iOS, and then otherwise for like desktop PC gaming, it's mostly through Steam and some of the indie stuff on itch.io. And then so I haven't seen a lot of like AAA games deploying specifically through the browser, and I'm not exactly sure why that is. Maybe it's their tool chain or something like that. But
I've had concerns about DRM and piracy, because once you have the WASM binary, you can just steal it.
Yeah, decompile it and whatnot. I can see that then. Yeah, but then I guess the only time that would make sense is if you have a server component like MMORPGs, where you can control like what's going on there. So okay, I can buy that. So so I can see like if it makes sense for the game, then like delivery through the game, and maybe just maybe like the days of Flash games will rise again, because I don't know if you remember Newgrounds. A good friend of mine, like he went to school with the guy that runs Newgrounds, Tom Fulp. And it was interesting because I also was into Newgrounds for a while, and I saw my future friend in some of the Flash games that like I was shooting him up and stuff like that before I realized that like I met him and stuff. So anyways, that's an aside that may or may not
Yeah.
stay, right? So
No, I mean, I think I remember there was a time when the web was really, really interesting, and it was all thanks to Flash Player.
mhm.
And then I think Newgrounds had a very, very nice ecosystem of Flash games,
Yeah.
and there was a lot of creativity going around. And actually, I think RuneScape. Did you ever play RuneScape?
No, I haven't.
Okay, so RuneScape, I don't remember whether it ran in Flash or JVM, like the Java plugin for the web. RuneScape was a very, very massively popular MMO RPG, the kind of the first of its kind
Uh-huh.
to run in the browser. And yeah, there was a time when the web was or at least games in the browser were very, very powerful. And of course, the JVM kind of got deprecated for most browsers. Flash got deprecated for most browsers, and
Yeah.
now web gaming is in a very sorry state, I
Yeah.
would say.
Yeah.
And
Yeah.
and maybe Wasm will bring that back.
Yeah, because what's lost with Flash gaming being down is that developers used to have a channel to experiment with their crazy ideas or indie ideas, and they could just kind of build out a level or two, or maybe they're just amateurs, like just putting out their first or second game. And a lot of times, if it happens to blow up, then they're like, okay, let's make a full-fledged game based on this concept, and we can port it to like other platforms. And it's kind of like a proving ground or like a minor league for games that doesn't quite exist anymore. Like a lot of times the launch, like the playbook for launch is a lot different nowadays, where you try to get greenlit on Steam and raise a Kickstarter campaign and so on and so forth. So yeah, if Wasm was more available for gaming, it would bring that back. I did know I was working with the Godot game engine, which is an open source game engine that is kind of the underdog to Unity and Unreal, and they've been gathering a lot of steam. And they do have an HTML5 compile target, which compiles your game to WebAssembly. So the tool is available. It's just we'll see if a lot of people make use of it.
Yeah, if I remember correctly, actually, you can run their editor in the browser itself, thanks to
Yeah, right,
that whole
exactly.
thing. So
Yeah,
they
yeah.
write their tools in Godot itself,
Yeah,
possibly.
Godot's written in Godot, and then they compile it to WASM and deploy it over HTML. That is correct.
Yeah, so that's kind of cool. And yeah, I think it goes back to this idea that there are a lot of powerful tools that people are running in the browser increasingly these days. So things like Figma for prototyping and design,
Yeah.
things like Canva, which is basically a Photoshop / Adobe Illustrator
Mhm.
thing in the browser. We mentioned Descript a bunch. And so, yeah, it would be a very, very interesting future if we start getting these kind of power user tools being able to run in the browser. And that's great because that means that they will be accessible in a variety of platforms. So, they'll be available to Linux users, they'll be available to potentially iPad users without the developers having to do a bunch of extra work.
Yeah, and the last kind of category I was thinking about, but I don't know if anybody's actually doing it, are the interactive REPLs that you see either in cloud management software, like say like Google Cloud, or in interview practice sites, in which you run some, like type some code in the browser and then run that code regardless of what language it is. My understanding of how these are usually implemented is they send your code to some backend running the language, and then it has to make the round trip to return the results. But if you can run a compiler in the browser itself, you probably don't need to make that round trip. Do you know if any practice sites are doing that?
I actually haven't seen any like official practice sites or interview sites, but I know that this is a real thing that people can do. So I've seen like a proof of concept where somebody was doing this for C++ compiler running in real time, and so yeah, that would be interesting, and that kind of goes into this like sort of back to this pyodide idea that you can have maybe an entire notebook ecosystem that runs in the browser,
that's
and
true.
maybe supports a variety of languages as well.
Yeah, and so those are kind of like the browser compile targets that I guess you and I have seen, and then we've also talked about like some of the stuff at the back end with the serverless and edge computing. Are there kind of other things that you've seen that people are doing with Wasm nowadays besides what we've mentioned so far?
Yeah, I mean, I saw a really interesting project called Lunatic. They did a show HN recently, and they are basically trying to take the idea of the Erlang ecosystem. So Erlang is a language that's known for having very good support for concurrency and fault tolerance. So basically, when you write your program in Erlang or Elixir, more popularly these days, you get the ability to run your programs as these sort of isolated units so that parts of your programs can crash without taking your entire program down. And so this makes for very nice long running systems. So you can have, systems that support massive concurrency. You can have bugs, parts of your program can crash and come back up again without bringing your entire service offline. And Lunatic is basically a runtime that brings those types of concepts, but allows you to write in any language using WebAssembly.
Yeah, I thought it was kind of pretty clever when I saw that too. I was like, oh, I should have thought of that because like all the elements were there in my purview. But like effectively, Erlang is a language from I think the 90s or so, where it was originally invented for the telecom system, and they have to handle a lot of concurrent connections and respond to them. And the programming model that Erlang embodies is the actor model, in which every process is isolated. It has no shared state. And the only way that the actors communicate with each other is through message passing into their inboxes, right? And so that makes the concurrent programming heck of a lot easier because they don't worry about like locks and semaphores and stuff like that. You just message pass and deal with the messages as they come in. And so one of the things about actors is that they're isolated. There's no shared state. And the Erlang VM implements this from scratch because they had no other other recourse. And so what's clever about Lunatic is that they saw WebAssembly and say, oh, WebAssembly has this kind of sandboxed property in which we can use this to mimic the isolation of the actor model. And so people complain about Erlang syntax and whatnot. So we will just bring this to the mainstream, and you can tell people you can bring your own languages. There's probably some constraints, but at the very least, you'll know what the syntax for the switch statement is, but you can still reap the rewards and benefits of a system that had only been available to programmers of Erlang and Elixir before. And so you can bring that kind of those properties to the systems that you architect now.
Yeah, I think the crazy thing about Lunatic is that you might actually be able to do this again with polyglot systems. So you could have an actor that is written in one kind of language, and then another set of actors that are written in another kind of language. And you can imagine that this would be useful potentially for a system where, let's say, your business logic is written in easy to use language like JavaScript, and then you have a computationally demanding core of your system that's maybe written in C or C++, and you can tie all of that together under one system that kind of runs together, and you have this message passing model so that the JavaScript part of your system is able to communicate with your C++ part of the system and all run as one service.
Yeah, I think the interoperability of programs seems promising, and it might be the thing that ties everything together, because you could compile even individual functions into WebAssembly and then be able to orchestrate it within the same executable, if I'm not mistaken, because I was thinking about Dino, which is a successor to Node. I also just realized that he just transposed NO and DE from Node to get Dino. But the same creator of Node created a subsequent JavaScript runtime called Dino. And one of its promises is that it produces a single executable for you to run, is one. But the other thing is you can use WebAssembly in Dino. There are WebAssembly module package managers, so you could conceivably pull in WebAssembly packages and call them out as libraries inside of Dino. And so the promise there is what you're saying with the Polyglot languages, in which I don't care what the library writer, like he could be from another ecosystem writing a different language. Like I just know that I can pull it in and use it and it would not be a problem. Because typically, like for well-known and well-tested libraries such as LAPACK, like the linear algebra package written in Fortran, but everybody like writes wrappers around it in their favorite language in order to leverage it. But in WebAssembly, you wouldn't have to do that. You wouldn't have to write wrappers. You would just pull it directly into your system and call it as is as a WebAssembly module.
Yeah, that's a really, really different way of programming than what we think about now, because everybody is in their own silos right now. So you have your package manager for your language, which supports a particular set of libraries. And then if you like something from another language, you can't really bring it in unless you use things like interprocess communication. So you run it in a different process and you communicate through basically text, or you port it over.
And with like the form function interfaces, the FFIs, and inevitably there's some sort of like mismatch because like some languages have types, others don't support these like data types and so on and so forth. But like if each language has already done the conversion into WebAssembly types, then like nobody has to worry about any of that.
Yeah, I think this is a good point to start thinking about the second and third order effects. Like, what will the world look like if this actually were to happen? Yeah. And one thing that comes to mind is that right now, if you have a new language that has some interesting idea, let's say that you want to have a interesting type system, let's say, you have this bootstrapping problem where your language now has to have its own library that communicates with database drivers. You have to have libraries that render to the GPU, render UIs, and everything else.
There's just a huge surface area in order to support like a really basic standard library for your new language, right?
Yeah, exactly. And so there are a lot of interesting programming language concepts that we don't really explore because we're like, well, I want batteries included. And if I want batteries included, that means that I have to use our favorite friends, Python, JavaScript, Java, et cetera, et cetera. Otherwise, I lose out on a big stable of libraries. And so now, if we can imagine a world where you can import any library that you want through WebAssembly, because everything is ultimately compiled down to WebAssembly, then maybe you'll be able to do things like have very, very hyper niche domain specific languages that are suited for your particular problem space. But at the same time, you're able to make use of the wide world of libraries when you need them.
Yeah, that's pretty interesting, because then perhaps for like certain parts of your system, you can leverage your favorite programming language that is well suited for that particular problem. So for example, we've talked about functional programming before. Like if it's in the area where you're writing utilities, it's probably better that you have some like input output. It's easily testable, and so it's stable. You don't have to worry about it. And the of state is confined and constrained into a place that has the domain logic. And so that's one. But I think the broader point is you might be able to attack ecosystems that have traditionally been sat on by specific programming languages for a long time, and the moat was unassailable. Like specifically, I'm wondering about something like Excel. Like there's not been a new Excel competitor for a long time besides like Google spreadsheets. And so if there was a way for your new spreadsheet like program to leverage a lot of the modules from different language ecosystems, and maybe not even spreadsheets, but like you maybe something like a notebook where you can leverage like Python's ecosystem of NumPy and stuff like that, then it's much easier to get up and running with table stakes. And then you can just kind of implement the new thing that you're trying out to see whether it has legs.
Totally. One thing that I think would be really cool in the notebook space is making use of the Python ecosystem like NumPy, but bringing in our old friend, the React reconciler, which is written in JavaScript. And so can you have like a reactive notebook that makes use of our standard data science toolkit? There are a lot of notebook projects that are browser-based, but they sort of have to shed all of the nice libraries and basically rebuild the data science ecosystem in JavaScript. What if you could just bring that in?
Well, that's pretty exciting, actually, because then I guess you can leverage some. If you're leveraging the React reconciler, you can leverage React hooks to build out your cells that we mentioned before, the computational cells, so that it's effectively a DAG of computation. So you don't have to worry about updating specific cells in specific orders, and then you don't have to rewrite all the modules that would have been available for you, and you can deploy it over the web. And as we talked about before, the web is really good for collaboration and sharing. So that is actually really, really exciting.
Yeah, I think it basically makes use of WebAssembly to use the right language for the right job. So if you have libraries that are available from one language, you can use them and sort of remix them with ideas that are developed in another language. And so if, for example, the reactivity aspect is well developed in JavaScript, you can somehow have a mashup between that and the data science aspect. And I'm sure there are many other mashups that can happen. So, each language has its own moat, like you mentioned. And so what happens if you're able to kind of have these worlds collide? I think you'll have a lot of very, very interesting programs that people wish could exist, but they wouldn't be able to do unless they did a lot of work in porting libraries from one language to another.
Yeah, because I guess it changes the calculus of like what you're able to do. It changes the design space, because previously you had to do like an either or, right? If I want this particular feature, I need to pick this language or ecosystem. But now it kind of frees you from those constraints to pick and choose from the buffet of stuff that's available in a lot of different programming languages. That said, I don't think all possible combinations are possible, because I know that there's a certain boundary that you have to draw between like WASM and the rest of your program. Like you do need to like write currently between JavaScript and WASM, like you need to write into a specific memory buffer for them to pass data back and forth. Like there's a specific boundary. So if it turns out that your problem can't reduce the answer down to something that is not like megabytes of data, then that may not be well suited. But but otherwise, if it's something that takes a whole bunch of data and gives you an answer like 42, then that's well suited, right? So so I think that is pretty interesting. We talked about WebAssembly in terms of its compatibility and interoperability that changes the second and third order effects. One of the things that people are excited about WebAssembly for is the speed that it has inside the browser. So maybe some of the second and third order effects are the typically high performance computing applications such as VR and AR applications delivered in the browser. Do you have any sense of that?
I'm not too sure about the AR and VR side of things, just because I'm not as immersed in that community. But in terms of high performance computing, one thing that I'm excited about is a project called TFJS. It's TensorFlow, runs in the browser. And so it's kind of what you're describing. You're able to run TensorFlow models and deploy them in the browser. And
TensorFlow being a machine learning, like deep learning library that you typically run on your own local computer to train neural networks, right?
Yeah, exactly. And our computers, the average laptop, desktop, or even mobile device these days is able to do things that are pretty amazing. So you can do speech detection, you can do face recognition, you can do a variety of things these days on a variety of devices. You don't necessarily need to ship that to some central server and run the machine learning model and then ship the answer back to the client. You can just do that client side. And so, something like TFJS enables you to push a lot of the machine learning tasks that you might otherwise have to run centralized inference in infrastructure for, and just have them run where they're needed on the clients.
Oh, that's also pretty interesting, because I guess like one of the things I've seen for deep learning is where people wanted to push the neural networks to the edge. So for example, mobile phones, so that they don't have to make the round trip, right? Because for something like Alexa right now, I think if your internet is not working, it just doesn't work. It's effectively broken because it can't access the speech to text algorithm on the server. And so it would be nice if those things were available, especially for applications where I guess it's something like GPS navigation, if you can like talk to it and it always needs to be connected. And like we mentioned in the very first episode about local first, like for areas that are more rural or less developed, networked, and our favorite environment, space, right? So, so like the Star Trek vision of talking to computer, tell me where Captain Riker is, would not work if it had to phone home to Earth for some speech to text recognition.
Yeah, that's very true. So I think that there is some interesting interaction between WebAssembly and local first software. Actually, I wonder if there are some interesting avenues there to explore, where you basically have WebAssembly clients that are interacting with each other through CRDTs and syncing their data and things like that. Yeah, that'd be super cool.
Right. And so we got to be careful before we heap in all sorts of new hype technologies, so that we get acronym soup of all the hipster technologies in there. But I hear what you're saying.
Oh no, we've discussed CRDTs in this universe. We've done a whole episode mentioning them, at least.
No, I'm just saying, I'm laughing at us in that once we do enough episodes, we'll think of an application that is a convergence of everything other episode that we've ever done.
Self-referential, right? Yeah. Oh, well, okay. How about this? We're gonna need WebAssembly, because one day a DAO is going to amass enough capital to send people into space, and they're going to need local first software, which runs on the local client using WebAssembly.
That is also running the React reconciler. Yeah, exactly.
Yeah. So I think that, in all seriousness, though, I think there is a lot of advantage. Again, not to rag on our favorite podcast editing tool, Descript, but it basically runs speech to text in order to transcribe the podcast that we record every week.
Yeah.
And then allows us to edit the text and conversely edit the video. And I think a lot of that just happens entirely on their servers. And it would be very, very cool if that happened on our clients so that you could do a lot of this while you're offline, when you're on a plane, or in whatever variety of environments. That would be a much preferable way of interacting with this type of software.
Have you tried out any of the Wasm tools or played around with it at all? Because when I played around with it, maybe about a year and a half ago, I found that there were still some edges that were still a little bit rough, especially the stuff around WASI, WASI. And it sounded like you had a little bit more experience with that, and you had mentioned it earlier. So one, have you experienced it? And two, you wanted to talk about WASI.
Yeah, so WASI is basically a standardized runtime for WebAssembly, or rather a standardized interface. So if you have ever taken a operating systems class, or something about operating systems, you know that in order to interact from your program to something like the file system, there is a standardized set of calls. And that changes depending on what environment you're running on. So if you're running on Linux, it has one set of calls to interact with the file system, to get permissions to make a network request, things like that. And that changes when you're running on iOS or when you're running on the browser. And WASI
is that typically what people have been calling like the POSIX, like POSIX, the interface like in Linux and stuff? That's what you're talking about?
Yeah, exactly.
Yeah, and then for Windows, it's like something completely different, right?
Yeah, Win32 or something like that. And I'm sure it's different for embedded devices and ARM devices and things. But so WASI is a interface that basically tries to standardize how your WebAssembly programs run, regardless of the system that's running them. So it enables this sort of narrow waist in that you can write your program, assuming that you have access to a system interface that supports all the functions that WASI supports. You want to write to a file, you want to open a file, you want to open a network connection, etc. And it basically translates that to whatever system that it's actually running on. And so it's a very interesting effort. It allows this portability that we're talking about. Without it, you would have to be very much aware of where your program is running.
So WASI is the thing, it's the standard interface that enables you to compile your WebAssembly into different compile targets, right? So that like it's not just for the browser, but you can compile it for back-end server, like whatever serverless thing, for presumably embedded devices also, right? So
yeah, and I think it's possible that if you have a standardized interface like this, you can be completely agnostic as to where your program is running, because a file is a file, a network socket is a network socket, a user is a user, and you don't have to worry, oh, am I running in the browser? Am I running on the server? And maybe it allows you to write programs where if you have a user that has a powerful client, you're able to ship your program and stream it and have it running on their device. But if you have somebody who's in a low resource compute environment, like they're running a really old Android phone or something, you can somehow dynamically adapt to this and say, okay, well, I'll run this workload on my servers instead.
I wonder if anybody's tried to write a WASI interface for, say, I don't know, the NES. I don't even know if it's possible, because the NES doesn't even have a clock, stuff like that. That might be too old, too low power, but it might be an interesting project for somebody. That was one thing that triggered in my head when you're mentioning it. But also maybe that thing that people do where they take Doom and they port it to all sorts of different systems and embedded systems, where like some people ran Doom on a toothbrush or something like that because they had like an embedded chip. Like maybe these projects would all be moot because effectively you just compile to WebAssembly and then they can go into any compile target, right?
Yeah, it would basically take the thrill away from a lot of those projects. But yeah, I think it's a very, very interesting idea. I am actually really excited about this idea that you can, with the standardized interface, be completely agnostic as to where your program is running, because we're seeing a lot of interest in streaming apps these days. So they're
What kind of streaming apps? Streaming the data or the apps themselves stream?
yeah, streaming the interface to the app. So things like in the gaming space, things like Stadia and Amazon Luna and things.
Is the game for Stadia and Amazon Luna, is it running on the server side and what they're streaming is a screenshot video of the thing running server side, or is it something where they're streaming the application?
It's basically something more like screenshots than anything else. But I'm sure they're doing all types of optimizations to make it less like you're just running over VNC or something like that. But as well as, actually, is it called the Incredible browser?
Mighty browser. Yeah,
Mighty browser.
Yeah, the Mighty browser. That thing stirred up a lot of emotions across the developer world. You want to explain real quick what the Mighty browser is?
It's basically a browser that's running in the cloud. The premise is that, Chrome eats up all of the available memory on whatever system it's running on. So why don't we run the actual instance of the browser in the cloud and stream the UI down to the client, so you can run it on whatever computer you want and have thousands of tabs open without actually taxing your computer.
Yeah. No, I mean, like, some web developers are up in arms about it. And I also think that it's kind of a ridiculous solution to this problem. But I say we only have ourselves to blame because we kept pushing out web applications that were like just slow. Just please, just get rid of the ads, fix your web application. Then people won't need the Mighty browser. But alas, like, we don't. And so that makes room for something like the Mighty browser to appear, right? But
yeah.
But at the end of the day, the Mighty browser then, like, do you know if they leverage like Wasm or WASI at all? And that's what you.
As far as I know, they don't. The reason why I'm bringing up these types of applications is that right now it's sort of an either or. So you're either running on your client or you're doing this like server-side streaming thing. But it would be very cool if you were able to write programs that could shift their workloads dynamically. So let's say you're running a game service, and you know that your user is in some country where they don't have very up-to-date computers. You might be able to dynamically shift more of the compute or more of the rendering onto your servers. Whereas if you know that your user has a very advanced computer, you're able to push more of that onto the client side and keep only some of logic on the server side, and be able to shift this on the fly. And I think WebAssembly allows this. If you have a standardized interface, you don't really care where your compute is happening as long as it's happening somewhere that supports WASI.
Actually, then does that mean, because I know WebAssembly has a streaming API where like you mentioned, like that, like you can start streaming parts of the WebAssembly program and it'll start like compiling, running it, and like running it before the entire program has gotten there, right? So then if that's the case, then I wonder if we can imagine a world where identity was a solved problem, where anywhere that you walk, you can provably say that you are who you are. And any computers that are in the room, whether it's computers that we think of typically as our laptops, or even the room size, like where the IoT devices that are around you, they would be able to load the WebAssembly modules that you typically use into your environment and run them based on your identity, so that now you're free from the hardware that you have to carry with you. You just have to like walk somewhere and the devices that are around you will load the WASM libraries or programs and applications that you typically use. So it completely divorces you from owning hardware, I guess is one way to think about it. So it's kind of like the very futuristic vision of a cloud where like even more so like people don't really know where the cloud is or what it does, but like now I don't even have to carry a laptop with me. I just have to go somewhere where there are laptops and I just start using them.
Yeah, I think that makes a lot of sense because if you think about how we use websites these days, I can log into Facebook on my computer. I can log into Facebook on your computer. It's a bit of a pain in the ass because I have to do two-factor and all of that. But once I manage to log in, it's my Facebook, right? Like just running on your computer. And the whole reason why this works is because you're able to access these applications through this browser interface. It can dynamically download whatever program I want just by, if I know the URL, it will download that application. And so right now that's constrained to this idea of websites and web applications, but you can imagine that you can do this with any application you want. I can, maybe do this with games. And so, like you're mentioning, if I am able to authenticate myself as, I am who I am, then whatever device, as long as it has compute, can act as a thin client and on the fly access, whatever workload that I typically access on my own devices.
Right, but the feature of streaming is also more seamless than like typing in like a password. Like you're right that it's analogous, but like I guess the dream of the metaverse is that there's a persistence to the digital objects that are around us, and I'm laughing because we're referencing ourselves yet again. But like we're starting to see instances of this with crypto and Web3, where you don't have a login anymore. You just have a wallet. And as long as you have the private key and like the passphrase for your wallet, like it doesn't, you're basically hardware agnostic. And so we're starting to see like beginnings of this sort of thing. And so I can imagine like identity being baked into you so that you don't even have to log in. You just walk into somewhere, and as you touch a piece of hardware, it'll load the stuff that's relevant to you.
Yeah. I think that makes a lot of sense. Like in a lot of sci-fi movies, you basically are able to take a program that's running and like fling it to some other place and have it run on some other screen.
Right.
And like I'm sure that the designers will figure out all kinds of interesting affordances. But at the end of the day, as long as any system is able to, take your credential and dynamically load whatever programs it needs, you're going to be able to create this seamless computing environment where you can walk up to somewhere and it will resume the computation that it was running on your laptop, in a new place that's, where right in front of you.
Yeah, and I wonder if you even need like a centralized service for that, because right now I use Firefox's feature to send URLs from like one device to another. Like if I'm reading a web page on one device, I'll send it to another device. And as far as I understand, Firefox uses a centralized server, so in some sense they know my reading history, right? But if you want some sort of privacy with that, then I think it would probably be possible for our favorite, I guess, decentralized databases or something else that is not controlled by a centralized server to deploy your application, like your WASM applications to you, so that like it's the cloud in every single sense, not just that it's like centralized somewhere. That's almost in Pied Piper territory, maybe.
Yeah, that's true. It is a very, very futuristic vision. Actually, going back to this metaverse comment, and I don't want to get too self-referential, but you know what? Let's do it.
Let's do it because because how else are we going to have any laughs in this podcast, anyways?
Yeah. So we brought up the idea that the metaverse was this idea that you can imbue the physical world with sort of magic, right? So you connect it with the digital world, which you can program and things like that. And so another thing that's interesting is, what if you could tie programs with physical locations? So you go to let's say a restaurant, and it has some program that once you're there, you're able to, wave your phone, over, an NFC tag or whatever, and seamlessly load the application that is associated with this place. Now, a restaurant is a little boring because basically what will you do? You'd load like a menu and ordering
maybe your favorite
thing.
dish or whatever. Like, yeah, I don't know.
Yeah, but like you can imagine, let's say you're at a tourist location.
No,
like you're
I
at the
have
top of the Empire State Building. Okay,
conference rooms, because like people are always like, I can't get the AV thing to work. I don't know what my settings were. So like if you go to like different conference rooms at different like companies, maybe it'll just save that sort of stuff for you, or bring your like AV presentation stuff so people aren't like fumbling around with their stuff. That's the best I can come up with.
Yeah. I think that's a good one. One thing that I was thinking about is like, what if you're in a place and you're able to basically download on the fly some kind of Wasm app that gives you basically an AR map. And so, you're able to kind of walk around the building or whatever, and it'll overlay some, interesting information that you need in order to get around or do some whatever task in that place, or like a mall or something. You go to a physical place
actually,
and then shop.
That is interesting, because there are some things like events, like you join a conference and they want you to download an app, and I sometimes just cannot be bothered, and the apps are never really high quality either. And so I mean, yeah, maybe if it's location based, it'd be a little bit easier, but yeah, I don't know. But I get what you're saying. Like, I wonder what the difference is between like walking to a place and getting an app versus like typing in a URL. And do I want apps popping in and out of my computing device as I'm moving through the world? Maybe not. Those are things that are to be answered. But it's the sense that you have context specific apps that are there right when you need it. And so in that sense, I get what you're saying. One of the things while working at Pebble, where we were thinking about applications of smartwatches, and one of the things that we talked a lot about was that the information had to be timely and context specific. And there's a lot of things that would have to feed into making that actually work. But one of the things is that the app already had to be loaded on your watch or phone in order for that to work. And so if the delivery mechanism is such that it's secure and in the environment around you, like location based, then that may make a lot of sense.
Yeah, there are actually efforts that are doing this in a centralized way. So iOS has something called app clips. So if you walk into a Dunkin' Donuts or something, which is a chain that's all around me, if you walk in there, actually iOS will suggest, hey, you're in a Dunkin' Donuts. Do you want to open the app clip, which is a kind of lightweight iOS app that lets you do something like place a mobile order without having to go up to a cashier. It's permissioned so that it doesn't have all the full access to your operating system like a normal App Store app would. So it's something that kind of comes in and out as you need. Obviously, this is platform specific. And if we really want to hold on to this idea of the open web and things like that, you could maybe implement this instead using Wasm programs that are tied to locations and things like that.
Well, but on the flip side, like we're more opposite of dystopian on this thing, but I can see that if people really don't like ads, they're gonna hate some of this stuff if people like abuse it, right? And I was thinking, like, if WebAssembly is runnable everywhere, then I wonder if it's a boon to worms. And so maybe not, because like WebAssembly is already sandbox, so maybe that really limits the damage that they can do. But I don't know, like I wonder if there's something to WebAssembly worms that could be run anywhere. Maybe they just wreak havoc by an empty while loop. Yeah, I don't know if there are protections against that sort of stuff, like a timeout or
Empty
like
while
resource
loops
stuff.
are so 1990s, man. You mean that people are going to be running crypto mining programs when
Oh,
you go to a
right,
restaurant or
exactly,
something?
exactly, exactly. What was I thinking? Really, like get with the times. Yeah. So yeah, I do wonder then. Yeah, like if there's something to that, but I think the promise of more seamless computing where it goes into the background, maybe just maybe like WebAssembly can kind of help with that, and not only just a thing to help developers with operational deployments and like compilation targets, but a way for computation to be available to anyone anywhere as long as they're somewhere within reach of a network with a device.
Yeah, so this feature sounds cool. What do you think it would take to get there? How far along the spectrum do you think we are?
I think it's still early. I mean, definitely like tools in the ecosystem are still early, and a lot of the programmers are insular within their own programming ecosystems. I think, if anywhere, that they would start to reach out is in specific domains. So, like we mentioned, like FFmpeg, where if you're building an app in various languages, you need to leverage that. Then that's where they would start reaching out and leveraging WASM. And I see a lot of the near-term applications that typically have been associated with desktop apps like video and photo editing, like being the first sort of things that branch out on the consumer side. On the back end, I'm not so sure about edge computing. I haven't seen a lot of like large apps that leverage it completely, but that's not to say it won't happen, but I guess we'll see. But yeah, I want to say that that's initially what'll be there. I don't think WASM's going to go away. The only thing I think is probably like infighting for people that are doing this in the standards body. But
Yeah.
short of that, it seems like the train is headed there, and people would have to keep it in mind for specific technologies that can leverage it well. That's what I think was the initial step.
I agree. I think one other side of the equation is the platform support. So it's well supported, like we're mentioning, in open platforms like the web and then server side. But if we want this vision to happen, that there's this sort of ubiquitous computing where it's supported on mobile devices or on some smart screens and things like that, then platforms like Android or iOS or whatever mobile operating system in the future will have to support this. Right now, these are very closed ecosystems. We're seeing some erosion of that in that there's a lot of court cases as well as antitrust cases being made that could in the future, maybe in the next 5 to 10 years, open up these platforms so that you can run arbitrary workloads rather than these approved workloads. And so I think that's the next step if we really, really want to get to the future that we're talking about, where you're able to have WASM programs running on your phone.
Yeah. And now that you mention it, I wonder if there's going to be like some way companies block the running of various, or they only allow specific WASM runtimes, or I don't know, some sort of like heterogeneity of the thing because it benefits their business model. But yeah, I guess we'll see. I think as long as people hold steadfast to the idea of interoperability, then I think we have a bright future with WASM. But I guess like all things, we'll see. Yeah. Though I guess it's an aside, and maybe we should leave this for another episode or somewhere else. Like, I wonder what happened to the JVM on the browser, because it's definitely declined in popularity. But maybe that would be serve as a warning to WebAssembly, but we'll see. Yeah, there's plenty of runtimes and platforms that have blown up and then fall into the wayside, and WebAssembly is not beyond having the same fate. Yeah, I can't exactly see what sort of market forces would push that.
Yeah, lots of lessons to be learned, lots of ideas in the graveyard in this path towards write once, run anywhere.
Mm-hmm.
I think that I'm optimistic about this technology because for the first time, I've seen a variety of languages supporting this standard language.
Yeah.
So, everything from C++ and C all the way to Python, all the way to very, very obscure languages, brainfuck, like you mentioned. So I think there's a lot of enthusiasm among the open source community,
mm-hmm.
and this is being well integrated in the open source world rather than having one company dominate it like Sun or Oracle with the JVM.
Yeah, and also I get the sense that the WASM intermediate representation is relatively simple to make an implementation for, and that's probably also why so many languages can write an implementation for WASM, because it's stack based, right? And if you've ever looked into Forth, it's a weird stack based language. The stack based is weird if you've never seen it, I guess. But typically the reason why people use Forth is for environments that are constrained, so you can actually have a programming language and runtime in a very constrained environment. And so I think WebAssembly kind of is the same in that sense. And so that's I think how you get the proliferation of different languages that can compile into WASM, which kind of helps along this sort of vision.
Mm-hmm. Yeah. So, we've covered the ground of all the different ways that WebAssembly can make the world better, some of which are realistic, some of which are contingent upon other things happening, like the metaverse. But overall, I'm feeling pretty optimistic about this. How about you?
To the moon, to the stars, right? Why stop at the moon? To the stars? Yes.
We are going to have WebAssembly programs that are going to power our interplanetary computers that are running on our spaceships.
Exactly, because nobody in Star Trek ever had an episode where I can't run my because this is an older version of the Enterprise. I just can't run 3.0. You haven't upgraded your OS, right? So yes. I think it's in the future for us.
Cool. All right. Well, I guess that's it for now. I'm Sri.
And this is Will. And this is the Technium Podcast. If you like what you hear, join us next week. In the meantime, share, smash that like button, subscribe. And what else do we say?
Comment down below.
Right. Not down here. Exactly. All right. We have our initial pitch, but our outro needs work. So come back next time. See if we can come up with anything better. All right. Take care. See you guys later.
Bye.
Bye-bye.